Hey, what's up, guys? So, at the beginning of this semester and term, we're starting with Chapter 5, and we're talking about the natural base E. So, we're going to first explore what does E even mean? What is that even about? So, we're going to try and approximate this value. Now, there are different sorts of ways that E is just a number, pretty much. E is a number, and it's one that mathematicians have found in a couple different ways. So we're going to explore some ways how you can approximate the value of E. So here it asks us to add this right here. So 1 plus 1 divided by 1 plus 1 divided by 1 times 2 plus 1 divided by 1 times 2 times 3 plus 1 divided by 1 times 2 times 3 times 4. So let's go ahead and in a calculator, let's figure out what this means. But first I'm going to write this down as if I'm going to solve the denominator. So I have 1 plus 1 plus, now 1 divided by 1 times 2 is 1 over 2. 1 times 2 times 3 is 6, so plus 1 over 6. Plus 4 times 3, that's 12, times by 2. And that's going to be 24. So 1 divided by 24, dot, dot, dot. So let's see what the sum is of this right here. So I have pretty much 2 plus 1 divided by 2, enter. And plus, that's going to be 1 divided by 6, enter, plus 1 divided by 24, and enter. And I get 2.708. Now we can keep going. We can do 1 plus 1 divided by 5 times 4 times 3 times 2 times 1, and we could keep going. But because we're always adding a smaller and smaller number, right? These numbers keep getting smaller. We go from 1 to 1 to 1/2 to 1/6 to 1/24. It's even going to be an even smaller number after that, and a much smaller number after that, and continually that number is exponentially just getting so much smaller. So we're adding a smaller and smaller number. So the function is actually just going to keep going towards a value around 2.7 something. So let's find another way. There's a different way that we can approximate E. So using this equation right here, this function right here, 1 plus 1 divided by x raised to the x power. And what we're going to do is we're going to plug in these values of x. So 10, 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th, 10 to the 6th. Let's go ahead and plug those values into these squares. So here's what I'm going to do. I'll go back to my calculator. Okay. So 10 to the first power is just going to be 10. So let's do 1 plus 1 divided by 10 raised to the 10 power. And I get 2.59-ish. Okay, now let's try 1 squared, which is just 100. So we're going to plug 100 into the x value spot. So that's going to be 1 plus 1 divided by 100. And that being raised to the 100 power. And that's 2.704. 2.704. All right, now 10 cubed, which is 1,000. So we got 1 plus 1 divided by 1,000 raised to the 1,000 power. So 2.716. All right, now let's try 10 to the 4th power. So I got 1 plus 1 divided by 1,000. This would actually be 10,000. Raised to the 1, 2, 3, 4, 10,000. I get 2.718. Now let's try 10 to the 5th. So 1 plus 1 divided by 1, 1, 2, 3, 4, 5. Raised to the 1, 2, 3, 4, 5. Enter. Oh, I must have messed something up. Anyways, I think we all get I forgot my my parenthesis up here. We can try it again. Just insert it here. 2.7182, which is just slightly larger than the one from above, which was 2.7181. So I guess we should add that in here. So 2.7182. Now the thing is, again, it's kind of the same idea of what's going on up here. We are continuously just this right here, each time x gets larger. So from 10 to 100 to 1,000 and so on and so forth. This number right here is getting pretty dang small. We're adding a smaller number. Not only that, but we're multiplying it, or we're exponentially multiplying it by a larger number too, but because we're dividing, it's getting smaller. We're continuously adding a smaller and smaller number. And we are approaching a value of 2.7 something. We're continuously approaching a value of 2.7, a little bit higher than 2.7. Now, this is the value of E. So far, just from here, I'll read from here. So far in your study of mathematics, you have worked with special numbers, such as pi. Now, pi we know is 3.141 ... It just keeps going. And I is a special number, which was the square root of -1, right? Another special number is called the natural base and is denoted by E. So E is a natural base. The natural base E is irrational. So an irrational number is a number that you can't find its exact value because it's just a repeating decimal, right? So like pi is irrational. A square root of 2 is also irrational. You can't find its exact value. And E, we can't find its exact value. So the natural base E is irrational and is defined as x approaches positive infinity, then that function that we just showed you approaches the value of E. So if I were to go back to my calculator and we go to graph it, so if we graph that one function that we were just working with, so that's going to be 1 plus 1 divided by x raised to the x power, and graph it. So look right here. So actually what I'm going to do for illustration, let me go down, and we're going to type in E. So there's actually a button for E. If you do second and then the divided button, you actually have something for E. So right here, you can see that the function, if I could keep going to the right, the blue line is continuously getting closer and closer and closer to that red line. That red line is the value of E on the Y. So again, the statement said that E is defined as x approaches. Let me kind of draw that graph right here. So that graph went like that. And there was a line right here. This line was E. Okay, now the green line, the function, this was the function 1 plus 1 over x to the x value. Now, as x approaches, so again, this says as x approaches positive infinity. So this is positive infinity on the x, right? This direction, that's going to positive infinity on the x. So as x approaches this, the function, so the green function right here, in the y direction is continuously approaching the line E, but never actually touching it. Never actually touches it. It's infinitely approaching that line, which is why it's hard to find that exact value, because it's infinitely approaching this value right here. And that's how you get the value of E. So E is approximated to 2.718288182, so on and so forth. Okay, so now that you have an idea of where we got the value E from, let's talk about what we use it for. So first of all, let's talk about how we can simplify expressions that have the value of E. So honestly, you can almost treat them like variables in some cases, but again, remember that E isn't a variable, E is a number. It's actually probably something that you want to note down, that E is not a variable. It is a number. It's an irrational number. Okay, so right here we have E to the third power times E to the sixth power. Now, if we think back to 4.2, where we use those properties of exponents, there was the product property, and the product property said that a to the n power times a to the m power is equal to a to the n plus m. So if we're multiplying and we have the same base, then we can add the exponents, which is what we can do here. So this becomes e to the third plus 6, or in other words, e to the 9th power. Okay. Now there was another one from 4.6 which said a to the n divided by a to the m power. So for dividing, and it has the same base, this is equivalent to a to the n minus m. So we can subtract the exponents. Now the thing is, this is being multiplied. So 16 divided by 4, or being divided. So 16 divided by 4, we can go ahead and divide those. So that's going to be 4. And then I have e to the 5th minus 4. Again, I can subtract the exponents because they're being divided and they have the same base. So this becomes 4 and then e to the first power, which is just e. Okay, so for here, again, thinking back to 4.2, hopefully by this point you guys are pretty familiar with those properties. You're going to need them all the time in algebra. So there was a property that said a times b to the n power is equal to, if they're being multiplied, then you can put it in a way, you could say, you can put it as you're distributing the exponent. So it becomes a to the n times b to the n. Again, this can only happen if you're multiplying or dividing, not whenever you're adding or subtracting. So I can take this, and because we're multiplying between the 3 and the e, I'm going to distribute this exponent. So it's saying 3 squared times e to the negative 4x times by 2. Okay, so 3 squared is 9. And then here I have e negative 4x times by 2 is just going to be negative 8x. Now, we don't like having negative exponents, and so with negative exponents, the property states that a to the negative n is equal to 1 over a to the n. So using the reciprocal, we can make it a positive exponent. So I'm going to flip this so that it's in a denominator rather than a numerator. So it's e to the 8x. Okay, so you can use your properties of exponents to simplify these type of expressions.